In this episode, we're going to talk about a problem that shows up in almost every cloud program sooner or later. Teams will do what works under real pressure, not what looks perfect in a policy document. That is not a criticism of teams. It is simply how human work behaves when deadlines, outages, and competing priorities collide. Secure defaults are the settings and patterns that are already in place before anyone makes a special decision. And the reason they matter is that defaults get used far more often than exceptions. When those defaults are secure, a team can move quickly without accidentally creating a risky service. And when the defaults are annoying or fragile, teams will bypass them in ways that create hidden exposure. The goal here is to build secure defaults for cloud application services that teams will keep, meaning the secure posture stays in place after the initial launch and survives the daily reality of maintenance, upgrades, and troubleshooting. This is less about one perfect configuration and more about designing a system of habits and guardrails that makes the secure choice the easiest choice. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.Author.me in the Bare Metal Study Guide series. A useful way to begin is to be honest about why secure defaults often fail, even when the security team has good intentions and strong technical knowledge. Defaults fail when they are designed as a one-time hardening exercise rather than as a product that must serve users over time. They also fail when security treats operations and developer experience as someone else's problem, because teams will always find the path that reduces friction. Another reason defaults fail is inconsistency, where different teams see different behaviors and begin to distrust the standards, so they copy whatever seems to work rather than what is prescribed. Secure defaults also fail when exceptions are easier than compliance, because exceptions become the real standard in practice. If you want teams to keep secure defaults, you have to make those defaults both safe and usable, and you have to make the secure path resilient to normal change. This means you are designing not only a technical baseline, but also the surrounding workflow that makes the baseline feel natural. When defaults are built with that reality in mind, they become sticky, and stickiness is what prevents drift into risky configurations. Secure defaults for cloud application services start with a clear definition of what an application service is allowed to do by default, because uncontrolled power is the enemy of durable safety. Most managed application services run with an identity, connect to other cloud resources, and expose some kind of endpoint to users or other systems. If the default identity is over-permissioned, then every new service is born with too much power. If the default endpoint is publicly reachable, then every new service is born with a large attack surface. If the default logging is incomplete, then every new service is born with blind spots. A secure default posture answers these questions in advance. What is the minimal identity capability a typical service should have? What is the default network exposure model? And what telemetry must always exist? Beginners sometimes think secure defaults are about turning on every security feature, but the smarter framing is that secure defaults define what is normal and safe, and then make risky capabilities opt-in and visible. That shift, from automatic exposure to deliberate exposure, is one of the most powerful ways to reduce misconfiguration at scale. One of the most important defaults is identity scope, because a cloud application service that can access many resources is a perfect pivot point for an attacker. The secure default should be that an application identity begins with no meaningful access to sensitive data until it is explicitly granted. This prevents the common pattern where teams copy a powerful role from a sample project and unintentionally give it across the environment visibility. It also encourages good design where permissions map to a service's real job function, rather than to a vague belief that it might need access later. In practice, you want defaults that help teams request or attach narrowly scoped permissions quickly, because the moment that process becomes slow, teams will ask for broad permissions to avoid delays. A durable default posture also separates environments, so the identity used for development does not automatically reach production resources. When you connect these identity defaults to earlier ideas like least privilege and blast radius, you can see the outcome clearly. Even if a service is compromised, the attacker inherits only the smallest set of powers needed for that service's purpose. Network exposure defaults are just as critical, because reachability determines who can even try to attack a service. A secure default for many internal services is private or tightly scoped reachability, where the service is not globally reachable unless it truly needs to be. This does not mean every service must be hidden, because user-facing applications may need to be public, but it does mean the default for new services should not be broad internet exposure unless the service is explicitly designed for it. Another key default is separating user-facing paths from administrative paths, because the administrative surface is often more dangerous and should not share the same exposure posture as user traffic. Even for public services, secure defaults can enforce encryption in transit, minimize exposed paths, and avoid legacy insecure behaviors. The deeper reason teams keep network defaults is that they reduce the chance of surprise, where a service becomes reachable from places nobody expected. When reachability is deliberate, the environment becomes more predictable, monitoring becomes more meaningful, and the accidental creation of durable attack surfaces becomes far less likely. Logging and observability defaults are what turn a secure posture into a defensible posture, because you cannot reliably protect systems you cannot see. A secure default should ensure that every new application service emits meaningful logs, and that those logs include the context needed for investigation, such as identity, request characteristics, and outcomes. It should also ensure those logs are retained long enough to support investigations that may begin weeks after the first suspicious event. Another important default is that logging should be protected from tampering, because attackers who gain access often try to remove evidence. Defaults also matter for metrics and alerting signals, because it is easy to build a service that works and forget to build a service that can be monitored. Teams will keep observability defaults when those defaults are integrated into normal operations, such as troubleshooting, performance tuning, and reliability work, rather than feeling like security-only overhead. For beginners, it helps to remember that logging is not only about catching attackers, it is also about understanding behavior, and that understanding improves both security and stability. Secure defaults that support everyday work are far more likely to remain enabled. Runtime safety defaults are another area where secure design must meet usability, because managed application platforms often provide settings that shape how code behaves under stress and under error conditions. A secure default posture typically avoids excessive information disclosure, meaning errors should not reveal internal configuration details that attackers can use to target the environment. It also avoids overly permissive debugging and diagnostic exposure in production, because those features can become entry points or leak sensitive context. Resource limits and throttling-related defaults can reduce the impact of abuse, such as traffic floods that force the service to scale in ways that create cost spikes or instability. Outbound connectivity controls, when thoughtfully applied, can reduce exfiltration paths by limiting where an application can send data. These ideas are not about crippling the service. They are about setting reasonable guardrails so a service behaves predictably and safely by default. Teams keep runtime defaults when those defaults prevent incidents and reduce pager fatigue, because nothing motivates adoption like fewer emergencies. When secure defaults also improve reliability, they become a shared win rather than a security-only request. A critical ingredient in defaults that teams will keep is consistency across the lifecycle, because teams lose trust when the environment behaves one way at creation and another way during updates and maintenance. Secure defaults should be consistent across environments, meaning development, testing, and production should follow the same patterns, with differences that are deliberate and justified rather than accidental. They should also be consistent across teams, so a service created by one group does not look radically different from a service created by another group. Consistency enables shared understanding, which reduces misconfiguration that comes from guessing. It also enables reusable monitoring and incident response, because if services are configured similarly, security and operations teams can interpret signals more quickly. One reason secure defaults drift is that teams customize them early and then forget what was changed, so later troubleshooting becomes a hunt through unique configurations. Consistent defaults reduce that chaos, which makes teams less tempted to bypass standards. For beginners, consistency is the hidden superpower of security at scale, because it reduces variance, and variance is where attackers and mistakes thrive. Secure defaults also need a clear and respectful approach to exceptions, because exceptions are inevitable in real architectures. Some applications genuinely need public exposure, some need special integrations, and some need unique scaling or runtime behaviors. The goal is not to eliminate exceptions, but to make exceptions deliberate, reviewed when necessary, and easy to track so they do not become permanent hidden risk. Teams keep defaults when the exception process is predictable and fast enough to support delivery timelines without pushing people into risky shortcuts. If the only way to ship is to break the rules, then the rules will be broken and the environment will become a patchwork of silent exposure. A healthy defaults program creates a path where teams can request a deviation, explain why it is needed, and apply it in a way that is scoped and time-aware. The most durable systems also encourage temporary exceptions to expire, so the environment naturally returns toward baseline. This is not about punishment. It is about preventing one-off decisions from becoming long-lived vulnerabilities. When exceptions are treated as managed items rather than hidden workarounds, trust increases and risk decreases. To make secure defaults durable, you need a way to reproduce them reliably, because hand-configured security does not scale and is easy to erode. Many organizations use automation and templates, so new services start with baseline settings already in place, and one common concept for that is infrastructure as code, IAC, where configurations are expressed in repeatable definitions rather than as manual clicks. The exact method matters less than the principle. Defaults should be codified so they can be applied consistently and checked continuously. Codified defaults reduce human error, reduce variation, and make it easier to detect drift, because you can compare what exists to what is expected. Teams are more likely to keep defaults when the defaults are not fragile, meaning they do not break during routine updates or require constant manual babysitting. A codified baseline also makes onboarding easier, because new team members do not have to memorize a long list of security settings to avoid mistakes. For beginners, the important insight is that durability comes from repeatability, and repeatability is difficult if every service is created through a unique manual process. Secure defaults should also be designed with clear ownership, because defaults without owners become outdated as platforms evolve. Managed application services change over time, new features appear, old features behave differently, and security expectations evolve. If nobody owns the baseline, teams will encounter new settings and make ad hoc decisions, which slowly undermines consistency. Ownership does not mean a single person does everything, but it does mean there is a responsible group that updates the baseline, communicates changes, and ensures the secure path remains usable. Ownership also includes tracking which defaults are most important and which create the most friction, because friction is a signal that the baseline may need refinement. When defaults are treated as a maintained product, teams are more willing to adopt them, because they see responsiveness to operational reality. This also reduces the risk of security drift through neglect, where the baseline remains frozen while the cloud platform around it changes. Beginners should remember that security in cloud environments is not static, and a secure default from last year might be incomplete or risky today if it does not account for current platform behavior. A secure defaults program must also account for how teams deploy changes, because defaults are only meaningful if they survive the deployment pipeline. Continuous integration and continuous delivery, CI/CD, is a common term for automated build and deployment workflows, and the key concept here is that deployments should not bypass baseline constraints. Teams will keep defaults when those defaults integrate with their delivery rhythm, so they do not have to choose between shipping and being secure. If baseline settings are applied at creation but can be overridden silently during deployment, then the baseline will erode quickly. If baseline checks exist but are noisy or inconsistent, teams will learn to ignore them. A durable approach makes checks clear, actionable, and aligned with real risk, so teams can correct issues without fighting ambiguous blockers. For beginners, the takeaway is that secure defaults are not only an initial setup. They are a continuous posture that must be reinforced as code and configuration evolve. When security is aligned with deployment practices, it stops feeling like a late-stage obstacle and becomes part of normal quality. One of the best ways to make secure defaults stick is to align them with reliability and troubleshooting needs, because teams keep what helps them in day-to-day operations. For example, consistent logging helps debug outages, consistent network scoping reduces strange connectivity issues, and least privilege identities reduce the chance that a bug causes widespread impact. When security defaults reduce chaos, teams feel the benefits immediately, and those benefits build trust. This is why overly restrictive, poorly designed defaults backfire, because they create operational pain and push teams toward exceptions. A mature approach designs defaults that prevent common mistakes while still supporting normal workflows, and it iterates when friction appears. It also provides clear guidance inside the organization on how to do the right thing, because confusion is a major driver of insecure shortcuts. Beginners should notice that security adoption is not only about authority. It is about practicality and predictability. Defaults that are stable, clear, and helpful become a shared standard that people defend, because they know what life looks like without them. It is also important to recognize that secure defaults must support different service types, because not all application services have the same exposure model or data sensitivity. A user-facing public application has different needs than an internal worker service that processes data, and both differ from a background job that only runs on a schedule. Secure defaults that teams will keep usually come in a small set of profiles that match these common patterns, so teams are not forced into a one-size-fits-none baseline. These profiles still share core principles, such as least privilege, strong logging, and deliberate exposure, but they apply them in ways that make sense for the service's role. If a team sees that the baseline matches their reality, they are less likely to customize it into an insecure shape. This approach also helps assessment and detection, because you can baseline behavior by service profile and spot when a service deviates from its expected posture. For beginners, the key idea is that secure defaults should be tailored enough to be usable, but not so fragmented that every team creates a unique standard. A few well-designed profiles can dramatically reduce misconfiguration while preserving flexibility. As you build and maintain secure defaults, drift detection and correction become the final piece that turns good intentions into long-term security. Drift is the gradual movement away from baseline, often caused by troubleshooting changes, quick fixes, feature experimentation, or evolving requirements. A durable program expects drift and designs for it by regularly checking whether services still match baseline settings and by making it easy to restore the baseline when drift is discovered. This is not only about policing. It is about protecting teams from their own forgotten changes and from subtle platform changes that alter behavior over time. Drift detection also catches shadow services that were created outside standard workflows, which is a common source of misconfiguration attackers exploit first. The important point for beginners is that secure defaults are not a single moment. They are a maintained posture, and maintenance requires feedback. When drift is visible and correction is straightforward, teams do not have to live with accumulating risk, and security does not depend on perfect memory. The environment stays closer to its intended design, which reduces both incident likelihood and incident impact. To close this out, building secure defaults for cloud application services that teams will keep is about designing security as the normal way of working rather than as a special effort people must remember under pressure. You establish secure identity and permission defaults so applications begin with minimal power and gain access only through deliberate, scoped grants. You set network exposure defaults that avoid accidental public reachability and keep administrative surfaces separate and constrained. You bake in logging and observability so every service is born with the visibility needed for detection, investigation, and troubleshooting. You choose runtime and feature defaults that reduce information leakage, limit abuse, and discourage risky convenience settings in production. You maintain consistency across teams and environments, manage exceptions as controlled deviations, and codify defaults so they are repeatable, checkable, and resilient. You align defaults with deployment and operations so teams experience security as stability rather than as friction, and you design for drift so secure posture remains stable through the churn of cloud life. When you do these things well, secure defaults stop being a document and become an ecosystem of safe, usable patterns that teams adopt naturally and continue using, because the secure path is also the reliable path.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.